All right, question number 11. So you have a slope field and you're given the solutions here. Which one of these solutions could match? And for this, when the answer choices are solutions, you should draw one of the pictures. So pick a point and then draw that and see, okay, what does that picture look like following the slopes? And is that a picture of one of these? And the answer is yes. It's one of this right there. That is an exponential curve. Up to the right, flat left, and -1 or whatever number it is. This is an exponential curve and it only matches with B. So it's good to know the graphs and your functions to know which one would match. Number 12, do you know your derivative rules? I'm sure. The derivative of 4x, the hook is 4, and then the formula is 1 plus 4x squared. Done. How about the other directions? Integrating, we need to... That isn't factorable. Oh, I know what we're going to do. We're going to complete the square here. That's a great one. So we're going to take -6, divide by 2, and square it. That's -3. Squared, that's 9. So what I'm going to do is this. I'm going to add 9 and subtract 9. Oops, it's a plus. And what's going to happen here is I can complete the square here. So this is factorable. So what two numbers multiply to 9 and add to -6? That's -3 and -3. And then 13 take away 9 is 4. This is now of the form of arctangent to integrate. So A is the square root of 4. U is the square root of x minus 3 squared, which is x minus 3. And then the derivative of that, the hook, is 1, which that is already. So it actually all matches. So the answer, the formula is 1 over A, and then arctan, and then U over A, plus C. So having this ability to complete the square, and then seeing arctangent, square rooting to find the formula, and so on. This is going to be by parts. So U is going to be sine 2x, which means du is going to be the derivative of that with a hook. V, or dv, is going to be x Let's do it the other way. What's the other way around? Let's do it the other way. So let's this be x, and the derivative is 1, and let this be dv. It's going to be better. And then integrate this. You're going to need a 2, so it's going to be 1/2. And then the integration of sine is negative cosine. All right. And now put it together. So the formula is uv minus v du which is 1. And now we just need to integrate this. So we have negative x over 2 cosine 2x. A negative and a negative. In fact, I might even just put plus 1/2 in front. The hook is 2. So we need another 1/2 to undo that. So the hook is 2, so we have that. And then the rule. So for cosine, it's just sine plus c. And you could also write that as 1/4. Another one. We're going to let u be arctan. So du is the derivative of that. And then dv is going to be 1. So v, the integration of that is x, and then the formula, which is uv, so it's x arc tan x, minus the integration of v du. So I just multiplied together. So when you go x times that, the numerators join together. This is a logarithm. So the derivative of this is 2x, so it needs 1/2. So it's x arc tangent x 1/2, and then the ln of just the denominator. Make sure you remember the absolute value bars for that. All right, turn the page. All right, we're going to separate this. So it's already been factored, so that's nice, right? So we have x minus 2, we have x plus 3, and then 3x minus 1. So we have a times x plus 3. We have b times x minus 2. And then we're going to let x equal a negative 3. So that gives me negative 5b. What is that? Negative 10. So b is equal to 2. And we're going to let x equal positive 2. So we have 5a. And then that's 3 times 2. That's 6 take away 1. That's 5. And divide. That means a equals 1. So now I can come back here and I'm integrating. So a is 1 over x minus 2 plus b is 2 over x plus 3. And then just integrate that. So it's ln x minus 2 plus 2 ln x plus 3. No hook there, plus c. There would be a hook if the derivative of the bottom had a hook involved, which it doesn't. Just remember the 2 there, that just goes in front. All right, number 17. To evaluate a limit, first just evaluate at the number. So if I plug in 0, the area from 0 to 0 is 0, and 3 times 0 is 0. This is L'Hopital's rule. So we're going to take the derivative of the top. Now, taking the derivative of integration, that's the fundamental theorem of calculus. They cross out, and then you just plug in. So that ends up being 3x squared minus 1 to the exponent of 10. And then the derivative of the bottom is 3. Then substitute 0 in again, and you get negative 1 to the 10 over 3. That's just 1/3. So recognize L'Hopital's rule. How do you take the derivative and integration? They undo each other, and you just plug in x for t, and then the derivative of the bottom, and then you evaluate again, and you get your answer. All right, use the differential slope field for the problem below. So the slope field of the differential shown is there. So can you sketch through 0, negative 2? There it is. So I can see what it's doing here. And I can see going down this way what's happening this way. It might be here, or it might be like that, like an asymptote. But I can see the sketch of the graph one way and the other way through 0, negative 2. Here I want to solve the diffie-q, right, through that point. So it's dy by dx. And we have 4 plus 4x squared and 3 over 2y. So we're going to solve this. So we're going to multiply by 2y. And then we're going to divide by 4 plus 4x squared. And then we're going to multiply. So we now separate the y's and the x's. Here on the left is y squared when you integrate. This one on the left is going to be arctangent. So a is the square root of 4, u is the square root of 4x squared, which is 2x, and u prime is 2. So that means this should be 2. So what it was over what it became, and then the rule, which is 1 over a, arctan u over a. That's just x, right? U over a. And then plus c. So then to get y by itself, you square root. Now it's going to be negative. Because the y coordinate's negative, this is 3/4 arctan, just x, plus c. Then we're going to plug in the point 0, negative 2. So this is negative 2. Plug in 0. Arctan 0 is 0. So this is all 0. So if I solve this and square it, c is equal to 4, so it matches. So then our answer is y equals x plus 4. And you solved it. All right, good job not giving up. Last page, right? All right, use the DiffyQ there, and then we're going to fill out the slope field here with each point. So some of it's easy, like when y equals 0, the answer is 0, so all these are 0 right here. The other way too, when x is 0, this is when y is 0, straight down is when x is 0, still 0. So the slope of 0 is a horizontal line, so we've already done most of it just by doing 0. Then if I plug in 1, 1, the answer is 2. If I plug in 1, 2, the answer is like 5, it's like really increased. 2, 1, it's 4. Negative is like the same but negative, like the same but negative, like the same but negative. And so there's the picture, the point containing 0, 2, in terms of what direction we're going. So it's a turning point and it's going up in both directions. That's what I can see from 0, 2. And this is approximate 1/2 using Euler's method. So that's a chart question. The derivative is 2xy, and then it's the change in x, which is 1/4, times the derivative. All right. So we're starting with 0, approximate 1/2 using change in 1/4. Oh, I got it. All right, so 0, 2. Plug it in, and it's 0. Plug it in again, and 1/4 times 0 is 0. And then you add 1/4. The change in y is 0, so 2 plus 0 stays 2. And then when we multiply it, 2 times 2 is 4, times 1/4 is 1. And then take that answer times, so 1/4 times 2 times 1. Anyway, ultimately it's 1/4 times 1, which is 1/4. And then here's our answer. We want 1/2, and then you add it, and the answer is 2 1/4. So the approximate answer to that is 2 1/4. In the space below, we're solving the DiffyQ. So dy by dx equals 2xy. Solve that DiffyQ. So I'm going to divide by y and multiply by dx, and I'm going to integrate it. This is a logarithm. The other side is x squared plus c. And then to get y by itself, we write it as an exponential. But I'm not going to write it as x squared plus c up there. I'm going to separate it. So it's going to be e to the x squared times e to the c. You could add them together. And then I'm going to do a substitution. So plus or minus here, we'll just make it a simple constant. So it's just a simple constant times e to the x squared. Then plug in 0, 2. So it's equal to 2. When I plug in 0, e to the 0 is 1. So that means c1 is just equal to 2. So the answer is 2 times e to the x squared. Done. And that's what it would look like. All right, 21. That looks like something. Calculus friendly. So the exponent I'm going to use is negative 1/3 because it's in the denominator. The derivative there is actually negative 2x. It was 4, so divide it. So that gives me negative 2. This goes away. And then we add 1 to the exponent. So negative 1/3 plus 1. That's like negative 1 plus 3. That's positive 2/3. And then times the reciprocal plus c. And yeah, the 2's cross out, could just be negative 3. Here we are going to factor. So x plus 3, x minus 3. And we have one with x plus 3 and one with x minus 3. Equal to x plus 4. So if I let x equal 3, then we have 6b equaling 7. So b is 7 over 6. if I let b equal negative 3, or x equal negative 3, I have negative 6b, negative 6a, I mean. So negative 3 plus 4 is 1. That gives me negative 1/6. So positive 3, yeah. So then my answer, when I go back here and integrate, these are the answers that I start with. And they're going to be logarithms, right? So it's going to be a is negative 1/6, then it's ln of what the base is, plus, oh, I'm going to run out of room here, b, which is 7/6, ln of what the base is, and then plus c. I think the more times we do this, right, the more efficient you are in terms of integrating and matching it up and doing the work that you need to. Like anything, right? The more you practice it. All right, last one. Find the average value. That's an integration question from 0 to 3 of the function 2 over x squared plus 1, and then divide by the difference of the bounds. So 3 take away 0 is 3. So that's 1/3. I'm going to write that. Inside is arctangent. So on the side, the square root of 4 is a, square root of x squared is x, and then the derivative of that is 1. So this needs to be a 1, what it was over what it became. So it needs 2 in front, and then the hook goes away, and then it's arctangent. Wait a second. First of all, it's 1 over a, and then arctangent u over a. And that's from 0 to 3. So if I put all this together, the 2 and the 1/2 cross out, and it just leaves me with 1/3. And then it's arctan 3 over 2 minus arctan 0, which is 0. And it's done. All right, Mr. G Math over and out. I hope that helped. Keep practicing. Don't give up. You're going to do great on the exam. I know it. Till next time.